studying this carbon stuff. Can anybody in the class answer this question? Why we are studying especially carbon and its compound, not the other chapters are also there. Okay. But what we don't study that chapter. May I know the reason? Like metals and like metals. Like why we are not studying sodium and its compound? Why we are not studying calcium and its compound? Why not oxygen and its compound? Only that they are the two specific chapters that we studied, and that is carbon and its compound and hydrogen. The two elements are there that we usually have the same chapter. Okay, and we studied about that. May I know the reason? Can anybody in the class answer me this question? No one. Okay. So let me tell you that why it is so. Actually, carbon is the first element that if we start doing the electronic configuration of the elements, okay, carbon is the first one that has two shells and having the four electron in their outermost shells. Carbon is the only, none other, none other elements other than carbon is going to have four electron in its outermost shells. Okay, carbon in nature exists in two different forms. Okay, like carbon 12 and carbon 14. These are the two isotopes of carbon. One is carbon 12, carbon 2, another one is carbon 14. Okay. Don't write anything when I will ask you, tell you, then you have to write. First, you need to understand. These are called the isotopes. These are called the isotopes of carbon, isotopes of carbon. They bear same chemical properties because their atomic number is same. Chemical properties is due to the outermost shell electrons. And since it is having both the electrons, both the types of atoms are having 2,4 electronic configuration. This is also having 2,4 electronic configuration. So both of them are having same chemical properties. So we'll say that outermost shells are same. Outermost shell electrons are same. So that's why they will bear the same chemical properties. Either it is carbon 10 or carbon 14. Now coming to the point here is one thing that why we are especially studying this carbon compound chapter. Why not the other types of elements we're going to study? Because if we do the electronic configuration of first three elements, first 20 elements, we'll see that hydrogen is one, then helium is two, hydrogen, helium. Then we have next one is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon. And then we have sodium, and then we have magnesium, then we have aluminum. After aluminum, we have silicon. After silicon, we have phosphorus, sulfur, chlorine, and then argon. If we do the electronic configuration, you will like 2, 1, then 2, 2, and 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. Here we'll have 281, 282. Just a minute. We have 2, 2. Then it will have 2, 3, then 2, 284, then 285, then 286, then 287, and then 288. You will notice that this carbon and silicon are the one which is going to have four electrons in outermost shell. And this silicon is going to have an extra shell. Carbon is 2, 4 and silicon is 2, 8, 4. Because of an extra shell, silicon is not, we can say that silicon is not so versatile in nature. It cannot make strong bonds because of effective nuclear force decreases, because the size of the atom increases because of an extra shell. You know that when we are having the size of the atom decreases as we increase the number of shells. Okay, are you getting my point? समझ आया?
Yes,
Size
sir.
of the atom
Yes.
increases as we increase the number of shells. So coming to the point here, if we see that silicon 284 and carbon 2, 4. So it is 2 8, and then 4. With the shell of 1, 2, 3, 4. And we check it for the carbon, we have 2 and then 4. So because of this one, the effective nuclear force with, from the outermost shell is very strong because the nucleus is very close to the outermost shell. So the electrons, if the element is making bond with the atoms, carbon atom, then it is a stronger bond because simply it is closer. You know that nucleus is responsible for holding the electron. So nucleus is closer, that's why. Moreover, if we check the case of silicons, because of an extra shell, the nucleus is far away, and because of that, it is not able to hold that. Are you getting a point? Are you getting a point? Okay.
Yes, sir.
So
Yes.
this is one of the reasons. So silicon is other element. The first is a small size. Second one is it's because of a small size, it can make bond stronger bond. Second one is tetravalency. Tetravalency. Because of tetravalency, carbon can make large number of bonds. Third one is small size, tetravalency, and after this one is we can say that it make covalent bond. Covalent bond is the second strongest bond after the chemistry, after the ionic bond in the chemistry. So covalent bond is it make covalent bond by sharing of electrons. So that's why we say that covalent bond is stronger bond, and that's why it is responsible for making large number of elements or compounds. Sorry, compounds with by making we can simply say that carbon can make large number of compounds is because of this special property, small size, tetravalent, covalent bond. Covalent. Okay, so just a minute, let me find out the file. Just give me a minute. Then we will start writing. And this will be- So start writing this one that in atmosphere, carbon is 0.03% present in the atmosphere. And in Earth crust, in the form of coal and petroleum, it is 0.02%. Okay, in the form of coal and petroleum. Atmosphere, it is in the form of carbon dioxide and carbon monoxide. Some traces of carbon monoxide is also found. CO, carbon monoxide. Okay, so note it down properly. Write it fast. Mineral is important. Done? Done, everyone? Noted?
No, sir.
Noted, please. चलो सो नेक्स्ट देखिए draw this one please. Why carbon is so versatile in nature? Note it down first. Well you done is that You done? Everyone done?
Yes, sir.
Right. That representation that because of a smaller size, so due to smaller size, the effective nuclear force in the carbon to the bonded pair of electron is more. Proper structure also due to small size. Second reason. Ron, done everyone? Free?
No, sir.
Ron. Done? Done?
Yes, sir.
Yes, sir.
And this one, covalent bond. Yes, you done. Noted.
No, sir.
Noted. Noted fast. When you done, please let me know.
Certain.
Okay. Now, what is catenation property? So, catenation is a self-linking property of an element. Catenation is a self-linking property of an element by the virtue of which it can make bonds to its own kind atom. Like chlorine make bonds to its own kind. Chlorine, oxygen make bonds to O2 in NO3. Sulfur can make up to sulfur S8 atoms can combine together. That is called self-linking property. But most of the element can self-link up to 8 atoms of their own kinds. After them, they become unstable and the chain break. Since no other element other than carbon show the previous three properties, all three properties same at the same time. No other element other than carbon show all the same properties that is shown by carbon. Okay, like small size along with tetravalency. If other elements are small size, but they are not tetravalent. If other are tetravalent, but they are not a small size. Okay, if someone having a small size and tetravalent, they do not make a strong covalent bond. So there are many reasons. Carbon is the only element that is going to have tetravalency along with small size and make covalent bond. Because of these special characteristics, which the other element do not show, carbon show catenation property to the maximum extent. Maximum extent means that it can make bonds with thousands of carbon atoms joining together. Not only the straight chain, in the branch, in the rings, okay, and in the straight chain. So that is called catenation property. So everyone please note it down. That what is catenation property? The self-linking property of an element by which an element can make bond to its own kind atoms. Example like oxygen, oxygen, chlorine, chlorine, nitrogen, nitrogen. Okay, they show, but they are showing property up to 2 or 3 elements. But in case of carbon, due to small size covalent bond and tetravalency, it show catenation property to the maximum extent. As a result, it can make bonds in branches, straight chain, and rings. Okay, this is the reason that carbon is going to have 3 million compounds. That's the main reason. This is the main reason. Got it? You understood? Yes or no?
Yes, sir.
Okay. So please note it down fast. Write it down first. When you done, please let me know. Yes, you done?
Yes.
Oh. So now I'm able to write that why do carbon is able to make large number of compounds by the others will. Bond is weaker than the ionic bond. Okay, and have low melting points and heating points. This is a reason. This might be a reason. Okay. Because ionic bonds is very strong as compared to ionic, but it is not so weak. It is enough strong. Covalent bond is enough strong. Okay. Now, there's a question came that both silicon and carbon have are tetravalent, but silicon can chain. It's like silicon is going to make bond, so it can make chain up to 7 to 8 carbon atoms combining together. Okay? Like if I'm going to, sorry, silicon can make chain up to 7 to 8 silicon atom combining together. Okay, and after that it breaks. Then it breaks. But if we keep on moving with carbon, it can make thousands of carbon atoms can combine together, not only in a straight chain but in branch Okay, but in rings. So why carbon is having a special property than the other silicon also? Although silicon is 2,8 4, silicon is also tetravalent. The reason is very simple because carbon is small in size, so effective nuclear force is very high as compared to silicon. This is the main reason. Okay. So note down the question and write the answer because the small size of carbon, the bonded pair of electrons have more effective nuclear force than the bonded pair of uh, okay, that in silicon. And because the small size, because of the small size. Okay. Got it?
Yes, sir.
Okay. Good. Done. Noted. Why not responding?
Yes, sir.
Other also.
Yes,
One
sir.
second. You're done.
Okay. So here we have one more thing. Can you tell me that if I ask you one thing here that even though silicon, I'm saying silicon, in silicon the radius is increasing, okay? Because of the outermost shell is going far away from the nucleus. As we compare with the carbon, so carbon is just this one. This is the nucleus of carbon, and this is the atom of carbon. Okay, and next one is this one is silicon. First, second, and third. Okay. So can you tell me that why the atoms of silicon if we check, it is also having 4 electrons. Okay. And if we check, this is also having 4 electrons. But even though the nucleus of let's suppose it is going far away. So, but the nucleus is also becoming powerful. The nucleus of silicon have 14 proton, 14 positive charge, and carbon is going to have only 6 proton. So why, even if the radius is increasing, so nucleus is also becoming powerful now. So then why it is showing? The reason behind it is very simple. Why it means the question is that if even though the size is increasing, let's suppose size is increasing, outermost shell is going far away from the nucleus, but the nucleus is becoming on the other side, nucleus is also becoming powerful no? In silicon. Then why it is still have problem that it is not able to make large number of them? The reason behind it is very simple, because as you know that silicon has an extra shell, and because of that an extra shell, the electrons revolve at faster rate. The electrons revolve at faster rate. This is 1, 2, 3, and 4. They revolve at faster rate. Got it? Got it? Yes or no?
Yes.
So when they revolve at faster rate, what is going to happen? The inner electrons also revolve 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Because of that 8 electron in the outermost shells, it revolves at faster rate. And the nucleus is not visible to the, even though it is powerful, but it is not visible. Because the inner electrons make a cloud around it. They are revolving at faster rate, that the nucleus is not visible to the outermost shell electrons. So this is the main reason that this is called shielding effect. So in silicon, because of extra shells, the electrons shield. Okay, are you getting a point? Are you getting a point?
Yes.
The inner electron shield the nucleus, and like the fan blade, like the fan, you see the fan blade rotates. When the fan blade rotates, the roof is not visible. Or similarly, when there is a sunshine, and we have the clouds, the sun's brightness or heat is not coming directly to the on the earth, okay, on the surface of the earth, or it is not showing so much heat, or we are not able to face so much heat. The reason behind it very simple, because the clouds are coming in between. The clouds same, when electrons revolve, they form electron clouds. In the orbit, they form electron clouds. And because of that formation of electron clouds, the outermost shells electrons are not visible. Sorry, the nucleus is not visible to the outermost shells. And that is called shielding. Okay. So even though the nucleus is powerful, but it is not able to shield. So note it down. Note this one, please. Have you noted this one? The shielding effect. In carbon, the shielding effect is less than silicon. So the effective nuclear force, which is called Z effect in carbon, is more. Means the electron that are the nucleus force or nucleus charge, the positive charge experienced by the outermost shell's electron in carbon is more as comparison to that of in. Okay, you got it? As compared to that on in silicon. Done? Okay. If you have done this one, please write the next one. Now, there's a question came that uh, are you not responding? Dayan, why are you not responding? Ritvika, Inan, why are you not responding? I was speaking. Hello.
Sure.
Why you keep your camera turned off? Are you getting
Yes,
me?
sir.
Everyone used to keep your camera turned off. This is not so.
I'm not
Now the
feeling
next
well
question.
today.
Now the next question that usually came. What is that next question? The next question is that why do carbon is not able to? Carbon has 4 electrons in its outer motions. Generally, we know that if it is sodium, the sodium will make 2 positive. Like sodium can make 281 and it can make Na1 positive. Calcium can make 282. It can lose 2882. It can lose 2 electron and will form Ca2 positive. Likewise, oxygen have 2,6 electronic configuration. We can gain 2 and will form O2, O2 negative by adding 2 electrons. The reason why carbon is not able to, carbon has 4 electrons. So its nearest noble gas can be helium and its nearest noble gas can be neon. With electronic configuration 2, 8 and 2. If carbon lose 4 electrons, so it will attain the electronic configuration nearest noble gas helium. And if it gain 4 electrons, then it will attain the electronic configuration to that of neon. But carbon, when carbon will lose, it will form C4 positive. When carbon will gain, it will become C4 negative. But carbon neither make C4 positive nor it makes C4 negative. Why? Means it neither lose 4 electron nor it gain 4 electron permanently. It shares. The reason behind it very simple because carbon carbon has 4 electrons in its outermost shell. If it lose first of its electron, let's suppose. Carbon has 4 electrons. But when it lose one of its electron, now it is 6 proton and 6 electron here. But when it lose one of its electron, it does not mean that this electron will remain, the shell will remain of same size. No. Now it is having 6 proton and 5 electrons. So when it loses, its size will shrink. It because the greater number of proton are attracting the less number of electron. It is like tug of war game. Here we have 6 members, 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. So both are same. Okay. If both people are same on the same side, then the rope will be at the center. And if one of the person loses, then this rope will shift more closer to this side. Same in the case of electron, because 6 proton are attracting less number of electrons, 5 electrons, so it will shrink the atom. Size of the atom will decrease. Now, if we have another here, like this, if it lose one more electron, then the size will further decrease. So as we go, keep on closing, okay, and you know that if we go keep on losing the electron, or carbon keep on keep on losing the electrons, so a point will come that it will not lose. Why? Because it is very hard to remove an electron from the outermost shells of an atom if its sizes keep on decreasing, because it will come more closer to the nucleus this time. Nah? Are you getting my point?
Yes, sir.
It will come more closer. Size shrink means the outermost shell will comes closer to the nucleus, outermost shell's electron. And now exponentially more and more energy. Like for example, if you remove one electron, you get 1000 joule energy. Now, if you remove the next electron from the same outermost shell, from the same atom, another it may be 1 lakh joule. Not the same. It may be 1 crore joule for the next. So it is very hard to remove all the 4 electrons because exponentially more and more energy is required. This is not exponentially possible. Same if we keep on adding the electron, the size of the atom will increase. Why? Because the number of electrons are increasing, so size of the atom will increase because of the repulsion force. Like you add 1 extra electron, so size of the atom will increase. Now you add 1 more electron, then the size of the atom will also increase, keep on increasing. And now the outermost shells will go far away from the nucleus. As it goes far away from the nucleus, it is very hard to hold these extra electron, 4 electron for the nucleus, because this nucleus is still having 6 proton. But it cannot hold extra 6 electron it's already having plus 4 electrons, total 8, 10 electrons. It is not practically possible for the nucleus, which is only having 6 proton, to hold extra 4 electrons. So neither it form ionic cation nor it form anion. It form simple by sharing of electrons. Okay, no, nor it form C positive, C4 positive, nor it form C4 negative. So please write it down fast. Stop. Write it down. Done?
Yes, sir, done.
Okay. Okay, right here.